Hello and welcome to the 10th video in the Hydraulics and Hydrologic System FE Training Quiz Review, and this one's a groundwater problem. Want to retain enough of it. So this one's going to take a fair amount of real estate, that's why I made some room. Alright, an unconfined aquifer 300 feet deep has hydraulic conductivity of half a foot per day. 2-foot diameter well is drilled into the aquifer and pumped at a rate of 50 gallons per minute. The radius of influence of the well is 1,000 feet. After pumping is continued for a long time for equilibrium to be established, what's the depth of water in the pumping well? In the FE review supplied reference, we find Dupuy's formula, which applies for this case. And Dupuy's formula says that discharge is equal to pi times the hydraulic conductivity times the head at location 2 squared minus the head at location 1 squared divided by the natural log of the radial distance to location 2 divided by the radial distance to location 1. In this particular problem, R1 is the radius of the well. It's 1 foot. Diameter is 2 feet, so half of that's 1 foot. R2 is the distance to the to the radius of influence, which is 1,000 feet. H2 is the head at 1,000 feet, which is 300 feet. H2 squared, we'll calculate that shortly. H1 squared and H1 are both unknown. Clearly H1 is the square root of H1 squared. K is given to us as 0.5 feet per day. Q is 50 gallons per minute. We're going to need that in cubic feet per day so that all the units or the dimensions are correct. So we'll go ahead and make that conversion now. 1,440 minutes in 1 day. Feet cubed. 7.48 gallons in a cubic foot. And so if we make that calculation, I believe we get, let's see, 5 times 1,000 is 5,000 over 7. Should be around well, we'll just use the calculator for that. 50 times 1,440 divided by 7.48 equals 96.25. And there's some fractional part, but we're going to use that. Feet cubed per day. All right, that's the setup. All we need to do is rearrange this equation to solve for H1. Let's do that. Q times the natural log of R2 over R1 divided by pi times the hydraulic conductivity is equal to H2 squared minus H1 squared. We'll simply move H1 squared to the left, move this to the right, and we come up with H1 squared equals H2 squared minus Q log R2 over R1 divided by pi over K. And we can put numbers in now and try to find an answer. So H1 squared is equal to 300 squared minus 9625 times the natural log of 1,000 over 1 divided by pi times 0.5 feet per day. Okay, so 1,000 divided by 1. I don't believe I just put that in the calculator. It's 1,000. Take the log of it. Multiply that by the 9625, and I get 66,000. Divide that by pi. Divide that by 0.5. And then we're going to take 300, square it, for a things of 47,670.03 feet squared, and we take the square root of that. So H1 is equal to the square root of 47670, which is 218 feet. Closest answer here is B, 220.